Statistics is the study of how best to collect, analyze, and draw conclusions from data. One of the most critical applications of statistics is in healthcare, in the design and analysis of clinical trials. Statistics is fundamental to reliability engineering, where the focus is on ensuring that products perform without failure over a specified period under stated conditions. Now, let's talk about population and sample. You can think of a population as a collection of persons, things, or objects under the study. To study the population, we select a sample. Now, the idea of sampling is to select a portion of the larger population and study that portion to gain information about that population. Data are the result of sampling from a population. What is a statistic? From the sample data that we took from our population, we can calculate a statistic. Now, a statistic is a number that represents a property of the sample. For example, if, if our sample contains shapes, we can count the number of each shape. The average number of circles is an example of a statistic. In our example, we collected a sample of shapes. This sample contains circles and squares. We can count the number of total circles and squares. Now we calculate the average of number of circles. We get a statistics of how many circles we have in this sample. What are the types of data that we can have in statistics? Most data can be put into the following categories: qualitative and quantitative. Qualitative data are the result of categorizing or describing attributes of a population: hair color, blood type, ethnic group, the car a person drives, and the street a person lives on are examples of qualitative data. Quantitative data are always numbers. Quantitative data are the result of counting or measuring attributes of a population: amount of money, pulse rate, weight, number of people living in your town, a number of students who take statistics are examples of quantitative data. Quantitative data may be either discrete or continuous. Now let's talk about sampling. There are two ways that you can obtain samples from a population. One way is called sampling with replacement. Sampling with replacement basically means whenever you take a sample from the population, you return that sample back to the population. So when you obtain another sample, you will have the previous sample back in the population. You can pick it up again and you can sample it. Another method is called sampling without replacement. Sampling without replacement basically means whenever you take a sample from the population, that sample is not available in the population. You will not return it back to the population. So when you make another sample, you will get different data from your previous sample. Talk about frequency. Here I have created this table as an example. In this table we have a population. Here all of this is our population, which is composed of shapes. We have circles, squares, and triangles. So here I have created this count whenever it's a circle, we put the 1 here. Whenever we find a circle, whenever we find a square, the same thing. 1 whenever it's a square. Here, a triangle, whenever it's a triangle, put a 1. This way, we can sum and we can count how many circles we have in total, how many squares and how many triangles. This is the total of each of the shapes. And for example, now let's say if we want to know the total of shapes, well, all we have to do is sum all our shapes. We have total of 18 shapes. To calculate the frequency, all we have to do is first, how many times a circle appears in the population. Well, we have already counted that it appears 7 times. Same for the square. We're going to put it here, square, on the triangle. We have already counted how many triangles are in the population. So now that we have the frequency of each, we can also calculate their relative frequency. The relative frequency is basically the ratio or the portion of the number of times a value of the data occurs in the set of all outcomes to the total number of outcomes. To put it in and to practice, here the relative frequency would be 7, which is the number of times circle appears, divided by the total number of shapes. And this is the relative frequency. Same thing for the square. How many times a square appears, or the frequency of the squares divided by the total shapes. For the triangle, frequency of the triangle divided by the total shapes, and this will give you the relative frequency for each of the shapes that we have in our sample or our population. Now, the relative frequency, if we are taking into account all the all this samples in our population, then the sum of our relative frequency should always be 1. If we sum all the relative frequencies for all the variables, we should get 1 always, if we are taking into account all of them. One of the most useful things about statistics is called descriptive statistics. Here we're going to look at the average and median and how to calculate them. Here I have created a small sample. Let's say this is a sample of weight that you have tracked over, let's say, a month or 2. You have taken several samples of weight. And you want to know what is the average and what is the median of this weight. To calculate the average, what you have to do is sum of the values divided by the number of values or number of samples that you have. First, we're gonna sum all the values, all the weights. This is the total weight. And then to calculate the average, what we have to do is first we have to know how many samples do we have. Here count is 7. 7 samples. So all we have to do is divide the total divided by 7. And this is our average. Now to calculate the median is relatively simple. All we have to do, I'm going to convert this into a table. Okay. Yeah, now it's converted into a table, and now I'm gonna sort it. I'm gonna sort it as descending. All values are sorted, as you can see, from in an increasing order. Median is basically the middle value of the whole sample. For this to work, the data has to be sorted from smaller to the biggest. If it's not sorted, then we cannot calculate the median. Once it is sorted, then all we have to do is pick the middle. You see, this one is right in the middle. There are 3 on top and 3 below. That's right in the middle. The median is 146.8. It's that simple. Here in Excel, you have tools. If you want to use Excel tools, well, you can use average and then select all the cells, and there you get the average. Median, same thing. Select the median function, select all the cells, close, and you get the median. This way you can calculate the median and the average. Let's look at a very useful feature here in Excel. And actually, there are many available tools nowadays that you can use for this, to draw graphs from your samples, so you can see a more descriptive way of your data. Let's look at how to do this here in Excel. Let's say I want to see this data in a graph. Well, all I have to do is select it, go here, the type of data that you want, click, and there you go. You can see this a more descriptive way. If we sort it descending, you have a descending data or this ascending data, as you wish to represent it. Now, for example, let's go back to the previous example. I want to see this data in a more graphical way. Well, let's go ahead and select the data. Here I'm selecting circle, square, and triangle, which are my variables, and the frequency, how many times they appear in my sample. I'm going to select the pie, 2D pie. Here in the pie, you can see in a more graphical way how many circles, squares, and triangles. And it shows you in a graphical way how many there are in your data. You can do the same thing. Let's try another one. Let's try this one also. Here also it's a more graphical circle. How many circles? 7. How many squares? 5. How many triangles? 6. And this is a very nice way to see your data. It is very intuitive, very graphical, and you can show it to, you're giving a presentation, you're trying to explain the statistics, your statistics to someone. You can use graphs, which are very useful, very easy to understand.